Okay, this lesson is broken into 5 sections. The first section, rules and principles. The first rule is that the Heisenberg uncertainty principle. This states that it is impossible to know both the position and speed of an electron at the same time. The second one you need to know is called the off-ball principle, and this states that electrons enter the orbital of lowest energy first, so they fill all the lower energy levels until they can move up to the higher energy levels. Third principle is the Pauli exclusion principle. This states that no two electrons can have the same set of 4 quantum numbers. And the last one is Hund's rule, and this states that when electrons occupy suborbitals of equal energy, 1 electron enters each suborbital until all suborbitals contain 1 electron with parallel spin. And you'll see this when we start doing the notations. So orbital notation is the first way that we are going to show where the electrons are in an element. With this notation, you need to know that the lines represent the number of suborbitals and arrows represent electrons. So I drew this little chart over on the right-hand side to remind you that the s orbital, or the sphere, can only be oriented one way. That's why we only have 1 suborbital. The p can be oriented 3 ways, so we have 3 p orbitals, d5 and f7. So the first example I'm going to do is for the element fluorine. And when you are doing these notations or configurations, you are going to read the periodic table like a book. So you are going to start on the top, you're going to read from left to right, and then you're going to go to the next line, read left to right. Okay, and you have to read what you're going through. So the first one, we are going through 1s, and we go through 2 elements. Okay, so you have to have a line. This is your 1s line, and you go through 2 elements, so you draw 2 electrons. 1 arrow has to face up, 1 arrow has to face down. Then you go to the next line. You're trying to basically read the periodic table until you get to the element that you want. So the next one, you go through 2s. So we're going to draw a line for 2s. And again, you go through 2 elements, so 2 arrows. We're going to keep going. And now you're going through 2p. Okay, so 2p, p can have 3 suborbitals, so the 2p section is going to have 3 lines. So this is your 2p. And you go through 1, 2, 3, 4, 5 to get to fluorine. And so based on Hund's rule, we have to fill each suborbital with 1 electron first before they double up. So 1, 2, 3, 4, 5. If you want to think of this like seats on a bus, people typically go to an empty seat until each seat has 1 person, and then you start doubling up. So you have to do 1 electron per suborbital until they all contain 1, and then you go back through and you double them up. So this would be the completed example of the orbital notation for fluorine. If we wanted to do argon, we would start at the beginning again. So you have your 1s and you go through 2. You go through 2s and you go through 2, so 2 electrons. You go through 2p, you go all the way through 2p. So 3 suborbitals for 2p, and you go through 6 electrons, or 6 elements. 1, 2, 3, 4, 5, 6. Alright, then we go to the next row, 3s, and you go through 2. So your 3s line, you go through 2, so 2 electrons. And then you go through 3p all the way to the end. So your 3p has 3 suborbitals, because it's a p, and this one has 6 electrons. 1, 2, 3, 4, 5, 6. So this would be your orbital notation for argon. So with orbital notation, once you get down to elements further down on the periodic table, like for example lead, you would be having to draw 80-some arrows to draw the orbital notation. So another way that we can kind of write the electrons in the element is something called electron configuration. So in this, the number stands for the energy level, the letter stands for the orbital or the shape, so that letter is always going to be S, P, D, or F, and the exponent stands for the number of electrons in this orbital. So I took our two examples from orbital notation and copied them over. How we would write this in electron configuration is you would write 1s, this is for fluorine, and you see you've got 2 electrons in that 1s orbital, so 1s2. And then you move on to the next one. You've got 2s, and you've got 2 electrons in that orbital, so 2s2. And then you move on to the next one, you've got 2p. You count your electrons up, and you have 5 in that orbital. So your electron configuration for fluorine would be 1s2, 2s2, 2p5. If we look at argon, you would have, again, you start at the beginning, so you've got 1s, and you've got 2 arrows, so 1s2, 2s2, 2p, you've got 6 electrons, or 6 arrows, then you've got 3s2, and 3p6. So your electron configuration for argon would be 1s2, 2s2, 2p6, 3s2, 3p6. So the good thing is that you don't have to draw your orbital notation in order to write your electron configuration. You just continue to read the periodic table as if it were a book, and you can go straight to your electron configuration. So if we wanted to do electron configuration for bromine, you start at the top again, so reading it straight through. 1s, you go through 2 elements, so this is 1s2, 2s2, keep going, got to go through 2p6, continue on 3s2, and then you go through 3p6, you go through 4s2. Notice the energy level, remember, changes for the D block, so then you go through 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3D10. Then you are back into the P block, which is the original energy level, so then you go through 4P, 1, 2, 3, 4, 5 to get to bromine. So this last one is 4P5. And that would be your electron configuration for bromine. Now again, that could take you a really long time for the elements that are farther down, writing out the full electron configuration. So there's something called the noble gas shorthand. The steps to writing this is, the first thing is you need to find your element. Second step, you need to go up 1 row and all the way to the right to the last column, which is your noble gases. You write that noble gas in brackets, and then you go back down to the beginning of the row that your element is in and finish the configuration. So I'm going to show you what this would look like using the example that we just did. Oops. Okay, so we just did the full electron configuration for bromine, and it looked like this. So the noble gas shorthand for that is you find bromine, you go up 1 row and all the way to the right, so your noble gas is argon. You would put that in brackets. So basically say you're going to start at argon and then you're going to finish the configuration. So start at argon and then you finish your configuration all the way to bromine. So you go through 4s2 and 3d10 and 4p5. So your electron configuration, your full one, is the starting at the very beginning. Your noble gas shorthand is where you've got the noble gas in brackets. So basically we just took the electron configuration and we put a noble gas, AR, plus that last section. And so that is your noble gas shorthand. That is much faster and easier instead of writing out the entire full electron configuration. The last way that you need to write things or show the electrons is in a Lewis dot diagram, and this is only going to show your valence electrons and the element symbol. So valence electrons, in order to find that, you need to add up the electrons in your highest energy levels. So for example, I wrote the electron configuration for bromine. Highest energy level is the highest numbers, so that number stands for energy level. So I've got 4s2 and I've got a 4p5. So you add up those electrons, 2 and 5, so you've got 7 valence electrons. And so you need to have 7 dots around your symbol. So the dot diagram, you need to write the element symbol, so bromine would be Br. And you need to put 7 dots around bromine. Now the other thing we need to look at is, are they paired or unpaired? And what I mean by that is you've got a 4s if you're looking at the orbital notation, and you've got 2, so that would be a pair of electrons. And then you've got your 4p, so p has 3 suborbitals, and you've got 5 in there, so 1, 2, 3, 4, 5. So this shows, let me get a different color. This shows 1 pair, 2 pairs, 3 pairs, and then you've got 1 unpaired electron. So to draw your dots, you need 3 pairs and 1 unpaired. And so you've got 1 pair, 2 pair, 3 pair, and 1 unpaired. And if you count up your dots, you've got 7 dots or 7 valence electrons. When you draw the dots, pretend like you've got a box around your element, so you want to put dots on each side of the box. Don't put them in a circle, or don't put them all together. You want them like on each side. One more example is with zirconium, so I wrote out the full electron configuration. Highest energy level here is 5, and you've got 2 electrons in there, so you have 2 valence electrons. If you drew that one little section as orbital notation, you've got your 5s and 2 electrons. So those 2 valence electrons, that's a pair. And so your Lewis dot diagram, you would write the symbol for zirconium, Zr. 2 valence electrons, so 2 dots, and they are paired, so you're going to put them together. So that is going to be your Lewis dot diagram.